Hello friends, today, as we all know, and the most common fact is that there is a supermassive black hole in the middle of all galaxies, which is also in the center of our Milky Way and whose photo we recently took. But what do you think of this word supermassive? What will be the size of this black hole? Well, to be honest, you won't believe that you will be shocked to hear that the black hole present in the center of our Milky Way galaxy is 500 times smaller than our solar system. Yes, you heard that right. That means it is as big as our sun and only the asteroid belt. Well, if you still don't understand, then it doesn't matter. Our supermassive black hole is even smaller than the dot you can see in this image. So in such a situation, what do you think? How big will be the size of the universe's largest ultramassive black hole to N618? Well, this video has been made to discuss it, so you are going to know very soon. But before that, I would like to give a small disclaimer. According to our modern physics, black holes are the only such single holes in the universe. Planets are objects whose age of growth has no limit, which means that they can grow infinitely with time. Yes, you heard it right. When we talk about planets, they can be as heavy as 10 Jupiters at the most, or they can grow in size because after that, their gravity will squeeze them so much that they will directly become stars. So after a limit, every planet becomes a star. But what is the limit of a star? Well, it also has a limit called the Eddington limit. According to this limit, stars can be as heavy as 250 to 300 suns at the most, after which they too collapse in their own gravity, and either a neutron star or a black hole is formed. Now, we have already discussed about neutron stars in previous videos that they also have an expiry date. When the fuel ends, it means life also ends. But this does not happen in the case of black holes. As I said earlier, it really has no. The limit is that they can grow in size and mass as much as they want, and the current modern science is proving it right now. Our current understanding of black holes clearly says that the biggest black hole till now has not reached its full size because of time. Because the universe did not get enough time after its birth to absorb all the things around it and become a monster in its size. That is, technically, there is no physical limit on it yet, or we have not been able to find it yet, and it is also clear that the universe has definitely not reached that limit. In the case of size increase of black holes, there is only one limit which is visible, and that is time. If it gets more time, then TOA 618 can become even bigger than what it is today, 10 times, 100 times, even 1,000 times. But here an interesting fact comes to the fore. If we see logically, then black holes always keep growing with time. The biggest black holes of today are the oldest ones. If black holes exist, does it mean that we have to go back in time to find smaller black holes? Well, in 1971, Stephen Hawking also talked about such a black hole in one of his theories, the primordial black hole. Sir Stephen Hawking had said in his hypothetical theory that apart from regular black holes which are created by squeezing matter, there are some black holes that exist in the universe which have never seen the shape of matter at the time of their creation. That is, simply put, they were created at the time of the Big Bang, that too from pure energy. So, after the Big Bang, for some very brief nanoseconds, the matter energy was one and the same, and at that time these hypothetical primordial black holes were formed due to the collapse or squeezing of this matter energy. That is, if these primordial black holes really existed at the time of the Big Bang, then such black holes can prove to be the oldest and most powerful objects in the world. The first atoms of the universe were themselves formed 3.8 Locke years after the Big Bang, and are powerful because some astronomers believe that what we consider dark matter are actually millions and billions of microscopic primordial black holes. And like today's regular black holes, they have the capability to gravitationally influence objects hundreds of times larger than themselves. And this is an interesting perspective to look at dark matter. Do you think that this is dark matter? Well, do write your answer in the comments, but believe me, a black hole as small as the size of a proton can also be as heavy as Mount Everest. And a black hole as big as a 25 paise coin can generate gravity as much as the Earth and make the moon revolve around itself. Interesting, right? Mesmerizing, I guess, but as I said earlier, this is just a hypothesis which James Webb or Hubble have not been able to prove practically yet. The black holes whose existence we have been able to prove till date are stellar black holes, supermassive black holes, and ultramassive black holes. If we talk about stellar black holes, then firstly, as their name suggests, they are formed by a stellar explosion or simply by the explosion of a star, meaning by doing anything, just squeeze a star beyond its limit and boom, your stellar black hole is formed. I mean, the size of the smallest stellar black holes that we have seen till now is just 17.2 kilometers. meaning 3 such black holes can fit in New Delhi city alone. And this small black hole revolves around the red giant star VI 723 Morn, which is 24 times bigger than our sun, around itself. Well, isn't it surprising that such a small black hole, which is so small in size, is controlling such a big star? We haven't even introduced you to the big member of this group. Meet him, this is M33X7, the largest non-stellar black hole in the universe. This gentleman likes to eat non-vegetarian food because despite being only 92 kilometers wide, it is currently pulling in a blue giant star as heavy as 70 suns, bit by bit. Interesting, right? Well, actually, what is even more interesting is that its discovery happened in such a way that recently when our scientists saw that the Triangulum galaxy next to it was emitting bright light equivalent to 5 Loch suns, seeing this, the curiosity inside them reached the 7th heaven. And after seeing what happened after that, everyone's eyes were wide open. They observed that this bright light is being produced from the friction and hence heat, which is produced by any star when it is absorbed in a black hole. In fact, such violent events eventually make black holes bigger and bigger, until it becomes at least as heavy as around 150 solar masses. If we want bigger stellar black holes, then we will have to take the help of hypothetical concepts once again, like the giant stars, which are millions of times heavier than the sun. Astronomers proposed a theory to justify the existence of supermassive black holes. According to this theory, in the early days of the universe, when the matter was very dense and stars and galaxies were being formed very fast, then many stars were formed more than required. By absorbing matter, they had become as heavy as 1,000 solar masses. As a result, their gravity became so intense that even before the complete star formation, only the core of those stars collapsed into a black hole. That is, externally, it is still a star, but internally, it has become an Earth-sized black hole. And this star with this unique characteristic was named Quaos stars. Inside these stars, heat is generated from strong gravity, and due to this heat energy, things expand and get pushed outwards. And in the midst of this tug of war of inward pull and outward push, the black hole present in the core starts eating its host star slowly from inside. That is, if such stellar black holes as heavy as 1,000 suns had ever existed in this universe, then it is probable that these Earth-sized black holes have merged and have become supermassive black holes today. As I said earlier, after stellar black holes of maximum 150 solar masses, the number of million times heavier supermassive black holes comes directly, and there's a very weird thing in you. In fact, our Milky Way's Vega Sagittarius itself is as heavy as about 4 million solar masses, and perhaps this is the reason that such supermassive black holes hold the galaxies at the center. Now I know you all have been believing this, but this concept is wrong. Unlike our solar system, where our sun holds 99.86% of the mass of the entire solar system, Sagittarius holds only 0.01% of the mass of the entire Milky Way. So clearly it is not the black holes that are keeping the galaxy stable. And well, recently in all the videos I have made on dark matter, I have always said in them that it is dark matter that holds the galaxy intact and in shape. And we had talked about primordial black holes some time ago, that they could be dark matter. So yes, hypothetically we can say that black holes hold our galaxy, but it is not that one supermassive black hole at the center. Friends, finally we come to the part for which you all have been eagerly waiting. The ultramassive black holes. Currently, at the center of galaxy OJ 287, almost 3.5 billion light years away from Earth, there is such a black hole which is revolving around another supermassive black hole that is 40 times bigger than our Sagittarius A, around itself as a satellite. Now, what should such black holes be called, brother? So, astronomers have come up with a new word, ultramassive black holes. Such ultramassive black holes have basically consumed so many stars, stellar black holes, and supermassive black holes in their entire lifespan, that literally, sometimes, such fountains of energy, that is, quasar jets, are created due to their gravity. Their accretion disk shines brighter than the combined brightness of thousands of galaxies. One would like to guess what their size would be. No, well, it doesn't matter. If we talk about the ultramassive black hole of galaxy OJ 287, it is so big that our 3 solar systems would fit into it. Whereas if we talk about the biggest ultramassive black hole, TON 618, then in front of it, our ultramassive black hole OJ 287 will look like a human being in front of a mountain. ton 618 is as heavy as about 66 billion suns, and its brightness is more than the combined brightness of about 100 trillion stars. As far as the size is concerned, brother, it is so huge that even if we travel inside it at the speed of light, it will still take a week to reach the singularity. And this estimate, by the way, has been made by scientists after studying its 10-billion-year-old image. And currently, it is 18 billion light-years away from us, which means after adding the size increase that happened in those 8 billion years above, now finally, how much time will the light take to reach the singularity? No idea. The thing that we have a good idea of is that whether the black hole is small or big, the thing that is present in the core of every black hole is the same. Singularity, which is nothing but an infinitely dense point, and anyway, the actual black hole is a singularity, but what we measure is the event horizon. So now in such a situation, how will you measure the size of a black hole? What do you think, using its singularity or using its event horizon? Well, what do you think? Write your answer in the comment section below. And if you got to learn anything new from this video, or your mind got blown after understanding the scale of a black hole, then definitely give a like. See you next time. As always, stay curious, keep learning, and keep growing.